So, the continuity equations describe how fluid flows through a pipes. The continuity equations states that in the case of steady flow, the amount of fluid flowing past one point must be the same as the amount of fluid flowing past another point. So, for our preparation, we will need 3 PVC pipe with 50 cm long each. Next, we will need T elbow or reducer for pipe connector. Then we will need stopwatch, we will need measuring cylinder, water sources, and last but not least, a container or bucket to collect the water if need. To construct a pipe model, we have to prepare 3 PVC pipes with minimum lengths of 50 cm to build a model of 3 junction pipes. In here, the model of pipe should be consist of one inlet converging into 2 different diameter of outlets. In here we should use a pipe connector, which is the elbow or reducer, to attach the 3 pipes to build your 3 junction model. Don't forget to prepare water, stopwatch, and measuring cylinder. After the pipe model is ready, use a stopwatch and measuring cylinder to get the flow rate of the water flowing through the inlet and outlet of your model pipe. So, when water is poured into the inlet of 3 junction pipeline, the flow will split between the outlet based on several factors. In the first place, flow rate division, because according to the principle of continuity, the volume of water entering the inlet must equal the combined volume exiting through the both outlets. However, the rate of flow will generally be higher through the larger diameter outlet due to reduced resistance and potentially lower velocity. Next, we will have pressure and velocity, because according to the principles of Bernoulli, if we assume steady, incompressible flow, the pressure and velocity relationship in each outlet will be affected by the diameter. The smaller outlet will have higher water velocity if we assume laminar flow, since it has reduced cross-sectional area, causing the flow to speed up to maintain the volume rate. Last but not least, flow resistance, which is the smaller outlet will offer more resistance to the flow, which may reduce the amount of water exiting from it compared to the larger outlet, depending on the internal friction and pressure condition within the system. So what can I say in here? The more water will likely exit through the larger diameter outlet, with flow rate differing based on outlet size, pressure, and resistance.
So flow rate is equal to Q times A, which is A equals to cross-sectional R of pipe. Then V equal to average velocity of fluid across the section. So, in conclusion, this project successfully demonstrates the continuity equation in fluid mechanics, showing that the flow rate entering a pipeline equals the combined flow rate at the outlet. The experiment confirmed that in steady state condition, fluid flow remains consistent throughout the system, reinforcing in the principle of fluid conservation in pipeline application.